Okay, this is the second and final video for section Seqr H. In this video we're continuing to look at mathematical induction. Now mathematical induction can also be used when working with inequalities. Okay, so you remember the IEAB module. Proofs for such statements often involve manipulating both sides of the inequalities, so a three-way comparison can be created and then reduced to the required inequality. Furthermore, the nature of positive integers and operations involving them are utilised in solutions. So let's look at an example. Prove n is less than 2 to the n for every positive integer n. So again, we're following that mathematical induction process. So our first step is for n equals 1. So we're starting with n is less than 2n. So my left hand side, if I substitute 1, is just 1, and my right hand side equals 2 to the power of 1, which is 2. Now the left hand side is less than the right hand side, so therefore statement true. Okay, and we can say M1 is true. Next, assume k is less than 2 to the k, so we're assuming that mk is true. So all I've done is plug k in. So part C is we need to show that k plus 1 is less than 2 to the k plus 1. Okay, as k is a positive integer. Now from there, you know that 1 is less than equal to k. So k plus 1 must also be less than equal to k plus k. So k plus 1 must be less than equal to 2k. Equation 1. K is less than 2 to the k, which is from my assumption. So that means 2 times k must also be less than 2 times 2 to the k. So 2k must be less than 2 to the k plus 1. And that's my equation 2. Now we haven't changed our inequalities in any of these steps. So if I come back to this step, you can see that all I've done was add k to both sides. So I haven't changed the inequality. Same over here. All I've done is multiply both sides by 2. So again, I haven't changed the inequality. So from there, if we combine equations 1 and 2, and we can do that because we have 2k here and we have 2k here, we get that k plus 1 must be less than and equal to 2k, which must be less than 2 to the k plus 1. So I've just combined those two statements. Therefore, going from this, k plus 1 must be less than 2k plus 1. So I've just taken this must also be less than this. Okay, so hence hem to the k plus 1 is true given mk is true. Therefore, n is less than 2 to the n for every positive integer n. Again, don't get too caught up in this. It's exposing you to mathematical induction and proofs. So what now? There is an exercise in the textbooks, just 3 questions, Seqr H2.